Everybody, and welcome to my session. I'm Cristian Prevedello, Chief Architect at Previnet. Me and my team at Previnet, we design new architectures for our customers that are insurance companies, banks, healthcare funds, pension funds. And other than designing the new architecture of these applications, we support the company with DevOps teams that are under my supervision. Why GitOps? GitOps got popular in the past few years as Kubernetes got popular as well. And we fall in love with GitOps when we started using it with Kubernetes. And as soon as we used it with Kubernetes, we wanted to apply the same methodology with our legacy infrastructure. This is just a subset of systems we are currently using in Previnet for our applications. We have Kafka, Redis, GitLab, Jenkins, HAPROXY, Vault, HashiCorp Vault, Zookeeper, Consul, and so on. We have different systems. Some of them are legacy. They are going to be replaced. But none of them, even if we are using something brand new, none of them, except Kubernetes, have an API interface like Kubernetes has. Some of them have a command line interface. Some of them have some old style file-based configuration. Others have API REST services and so on. So what we wanted to do was to abstract the way we could operate and configure these systems and turn them into managed resources managed by our GitOps platform. Then we sat down and we said what we want to do with our GitOps platform. It must be fully declarative. We don't want the developers to say to our operation guys or DevOps guys what they need to do. They must say what they want to do, and then the platform must act and perform the required changes to bring that infrastructure in the target state. It must be fully automated. We don't want our guys to manually tackle with our infrastructure. It must be fully auditable, must have a complete tracking what's going on, must have a fine-grained privilege system. We employ the security by design approach. We have different actors, junior devs, senior devs, team leaders, operations, DevOps, and so on. So we must apply different privileges to different actors. We must support segregation by environment and by customers, and also by application. Our customers are very picky when it comes to security, so we have different scenarios. And finally, we wanted to employ something very similar what our devs are currently using to develop their application that is basically based on Git flow-like. So the ingredients are not many. We have just a GitLab instance where we put all our YAML files that are used to create the request to apply the change management to our infrastructure. We have a combo composed by Jenkins that is a scheduler, as a job scheduler, an executor, and ANSIBLE playbooks to perform the required changes to the target system. It's not about just the technical part, but we wanted to take two birds with one stone and also be able to manage our process from a change management, traditional change management perspective. So as soon as we want to manage a new resource, what we do is to design the process that is behind this change management. So we identify the actors, we identify who's in charge of approving if there's an approval, which is the system or the systems are that are impacted by the change management. This is a typical, a very common pipeline where there are the devs that create a request. These requests go through an automatic validation process. And then there's a human approval performed by the DevOps or the operations guys. And then there's the final stage where the change management is brought on board of the target system. So everything starts here. When the dev create a branch into GitLab and they commit their files there, The files are basically YAML files. They are very similar to the ones that we are using right now in Kubernetes. Each file has two mandatory fields, that is the API version and the kind. The API version gives us the flexibility to be able to evolve the schema without breaking things that are already committed and that were already sent to production or to a staging environment. The kind identifies the type of change management that we want to bring on to process. In this case, we are requesting the creation of a reverse proxy rule into our balancer HAPROXY. Everything else, farm name, spec, and so on, they are specific to the kind that we are requesting. In this case, for those of you who are familiar with HAPROXY, we want to create a new reverse rule in HAPROXY, so we have to specify the front end where we want to publish our application. We have to specify the back end where we must route our traffic from the front end, the context of our web application. And in this case, we want to create also an ingress resource in our Kubernetes cluster. So in this case, we are managing two systems completely unrelated with one single request. So as soon as the developer commits these YAML files, Jenkins is notified with this new request, and a discovery pipeline is triggered through a webhook. GitLab pushes all the information about that commit to Jenkins, and there we have a job listening to these events where we can process the request. The discovery pipeline doesn't have many intelligence on board. It just performs some syntactic validation about the YAML files that it has just received, basically sort out the request. We are tracking all things that are happening into our GitLab repository. We are checking if this request was already sent once, if it was failed once, if it's just an update. And basically, we are using GitLab as database in this case. We don't have any external database for this activity. We want to just have GitLab. And so we are heavily using tags to track what's going on. This discovery pipeline also have the duty to send out notifications. Okay, I took on charge this job. We are processing this job, and it has this pipeline also has the duty to trigger the job scheduler that those jobs are the real workers that they bring on board the change management into the target system. The executor jobs are composed by two parts. One UI that is used as the front end for the end users that want to interact with the platform, and plus the ANSIBLE playbooks that are used to modify our change infrastructure. There's another part that is still under development, that is Uber orchestration, that we talk at the end of the talk, that is basically embedded into the discovery pipeline. So the Jenkins job executor, how does it work? Everything is developed with customer developed directives in Groovy. It has the duty to perform some privilege management. Each pipeline has their own configuration, so it checks if that action is allowed, triggered by that user or not. It embeds inside this pipeline the approval process and the workflow. So in the pipeline that we just saw before, we have two steps and two automatic steps and one manual approval, and all this logic is managed by the job executor. Basically, we have we came at the conclusion that we have one pipeline stage per step that we identified in our business process. Of course, these pipelines can be very lengthy, can take a while before they complete, especially when it comes to user input. So what we are using is nodeless stages to prevent the executor starvation, because if you have a stage that associated to a node, that worker is busy and is not available to perform to run any other jobs. So as soon as we need to gather some input from users, we basically move to a nodeless stage, so we can free up the executor and we can run in parallel other jobs. While we associate those stages that run Ansible playbooks to a specific node, so we can basically run in a high availability fashion our jobs. The job, basically, after it's sorted out the privileges, if everything is in order, we run the Ansible playbooks. Ansible playbooks, they perform the functional runtime validation, even if the YAML is valid. Getting to the example we described before, the farm that the user has specified is really existing, or maybe they made a typo. So here, the Ansible playbook is checking the request against the live system, if those information that were requested, they make sense from a real perspective. They bring on board the change management onto the target system. They can provide data for following stages for complex pipelines where maybe we get some information from the system and we must provide some information to the approver user. This data is prepared by Ansible playbooks. And most important, they are independent. Basically, we want to be able to run by mistake multiple times a playbook without breaking things. That's what happens with Kubernetes, and we wanted to have the same behavior here in our GitOps platform. This is basically a Jenkins file for our job of creating a reverse proxy rule into HAPROXY. Like you said, it's very, very short. Basically, we are saying that we are using an approved pipeline that is basically composed by a manual approval from a human. We are specifying the inventories that basically is composed with some data that is providing the dev user. This pipeline requires two different playbooks, one for the validation, one for the promotion. Basically, what's going to happen when I promote I approve the request. The validation playbook basically doesn't make any change to the end system, while the promotion playbook, they modify the system. So what's going to happen into our playbook is we have here the HAProxy cluster. In this case, we have just two instances. We have the Kubernetes cluster, we have Ansible, and everything starts from GitLab, where we fetch the information, the YAML file that the user committed to GitLab. Then we get basically our current HAProxy configuration from GitLab, because our configurations are stored in GitLab, not on board our cluster. The source of truth is GitLab for us. We create a new version of our HAProxy.cfg with basically our new additions that are coming from our YAML request. We validate this new file, bringing on board of the clusters without, of course, modifying the current runtime configuration. And if everything is okay, in this case, we have to also create the ingress resource. And so we created the ingress resource YAML file. We validate it if everything is all right. And if everything is okay, we send out the email to the dedicated parties that are in charge of approving this request. So we are here when we send the request validation, and what the end user that is in charge of approving the request, they get this screen into Jenkins where we display exactly what's going to happen if they click on proceed button. So we display exactly the lines that are modified or added to HAPROXY configuration file, and how the ingress resource will be applied. As soon as the end user, the approver, approves the request, basically Jenkins brings on board, triggers the final stage and runs the dedicated playbook that is basically performing the change of our HAPROXY configuration and of our Kubernetes ingress resource. As soon as everything went smoothly, if there's no problems, Jenkins notifies the developer that the change management has been successfully completed, and we can also notify other parties just to be sure nobody is out of the loop. How we can structure our branches? We said that basically we wanted to have something Gitflow-like, and basically in Gitflow, you create a merge request that is reviewed by someone, and then this merge request is, when is approved, is merged into our final destination branch. The problem here is that inside a branch, we can put different kinds. So the idea is that we create a package of YAML files that maybe they request the creation of HAPROXY, reverse proxy. We create, we must create some topic on Kafka. We must create some database. The idea is to create this package of requests and commit all together into the system. In this case, of course, we can't merge the entire branch into maybe the testing branch where we currently have all current state of testing infrastructure, because maybe some YAML files have a faster approval cycle than others. So what we do is copy file by file into the destination branch. So everything starts from an empty branch. As soon as the request, the package is ready, the developer creates a branch with this naming, release, testing, and whatever they want, my application, for example. Basically, the second part of the testing identifies the destination environment where we want to run our infrastructure change management. At this point, all the files that are contained into that branch are processed independently, and here Uber orchestration comes into play, as we'll see later. And so each file is processed independently, and as soon as a file has been successfully processed, we copy this file, so we don't merge the branch, we copy this file into the destination environment branch. So the testing branch, we also have branches for staging, UAT, production. This is just the most used environments that we have. The testing environment has a full picture of what's currently in that infrastructure at that moment. That not necessarily is exactly what the user requested. If everything goes okay for testing, we can basically take that branch and create a new branch for staging environment and so on. So we can promote our request through our higher environments until we reach production. Of course, some requests are not they can be reused, because when we request, for example, a creation of a reverse proxy rule into our HAProxy staging farm, the staging farm is for staging, is not for production. So some files must be modified and must be replaced for higher environments. This is, for example, another simple pipeline that is used by our for our deployments. We don't have any here. We don't have any approval stages, because our approval for deployments are performed elsewhere. So in this case, as soon as we create a branch for creating for deploying something, that goes straight to the dedicated environment. Another very important part is how we can communicate between Jenkins and the Ansible playbooks. They are two different unrelated systems, and basically the controller is Jenkins, that has also all the information about what's going on about the specific job. So what we created is an Ansible build context that is generated by Jenkins, and basically this context brings all the information that Ansible needs to know to be able to perform their activities. We are passing out, for example, the workspace where all the data has been checked out from GitLab. We are passing the environment. We are passing the item kind, the files, and so on. This is very important because Ansible is very stupid for what concerns the external world, and so this is the only input Ansible playbooks that receives to perform their duties. So Uber orchestration, what is this about? Like we said, we can, with one single job, we can manage one or more pieces of infrastructure. That's good, but that orchestration is inside the specific job. But what if we want to, for example, create a reverse proxy rule and a new front end? We want to create a reverse proxy rule for a new front end that is not already there. If we process independently these two requests, for sure, the reverse proxy rule will fail because the front end information is not already in the HAProxy configuration file. So what's happening here, that we need in some way to be able to compose at a high level some existing jobs. And we need to create some sort of dependencies between jobs. So, for example, if we are requesting a new reverse proxy rule, and in the same batch, we are also requesting a new front end, it's likely that we want to wait before running the reverse proxy job and wait that the front end job is completed. Otherwise, we will get a failure for sure. So Uber orchestration basically let us to run different jobs that are somehow they have a dependency between them, and run them in a specific order. And this is more tricky because so far what we did was very, let's say, was simple. Basically, we are writing down Ansible playbooks using very often some already existing modules to operate with files, with the configurations, and so on. But here, things got more complex because developers are very creative, and so at some point they end up with bringing, they want to create a full stack from nothing that involves database, new virtual hosts, registration into DNS, creation of secrets, creation of the topics in Kafka. So basically, as soon as we are using this platform, they want to do everything with this paradigm. And so it became very tricky to be able to specify the correct rules without basically waiting and making too much, too many locks. Because another parts that we have to face is, for example, can we run in parallel to HAProxy jobs? No, because since we must wait the approval from someone, we are not able to perform the change in a secure way, in a parallel way. So what we are going to do is put on hold future additional requests that are impacting the same HAProxy server until basically the previous request has been completed. To do this, we use the lock directive that is available in Jenkins. But the risks to perform this is that basically we are not able to run very fast and basically perform all our jobs in a sequential way. That is not our idea. With Kubernetes, we apply all our YAML files, and then it's in charge of Kubernetes sorting out what needs to be done in the correct order. So Uber orchestration is very important, but it's tricky to be correctly configured. So our challenge is about our platform, which is the main problem that we encountered during our development. Basically is, how can I say, to be able to run in an independent way our playbooks, because some when you are dealing with configuration files, more or less it's rather easy. But we have other systems that they have a very old interface, and it's not so easy to apply the same change management without breaking things. So a lot of stuff, a lot of code was written to be sure that things were not already there. So for sure, developing independent playbooks was not exactly easy. We had to put some effort there. We had to put some effort into designing our pipelines. For example, Jenkins is not exactly helpful when it comes to secrets management. Jenkins is very, very bad when it comes to secret management. For example, when you store a secret into a parameter, into a pipeline, that secret stays there. Even if there are some plugins that are aimed to reduce this problem, indeed, we were not satisfied. So what we did was to develop some plugins that manage in a different way our secrets management. We are using this platform to bring on board, for example, secrets into Kubernetes or into Vault. And here we found out that Jenkins was storing data here and there, and it was a nightmare to be sure that the secret wasn't staying around. So we had to develop some plugins and also specific directives to be able to manage our our data. For example, this screen is managed by a custom plugin to be able to provide an HTML Git-like diff about our infrastructure, and we weren't satisfied by current way that Kubernetes, that Jenkins were presenting our data, so we developed our own plugin. So it wasn't rather easy, but we are pretty satisfied. And basically nowadays we solved a big problem for our devs. Traditionally, they were sending out emails and they had to wait that the ops or DevOps guys were performing the activity. That activity was performed manually, and so it took time, it was error prone, and so on. With this platform, we basically automated everything, and so we are able to proceed at a much faster pace from a developer perspective, and they are much more independent right now. Some processes are completely automated. Maybe they are automated for a lower environment, and they are not automated for production. The platform manages this as well. So what we solved is to give more freedom to our devs without sacrificing, without losing the control, without losing the possibility to manage properly our requests. I think that's it. I don't have anything else to add. If there's any questions, I'm very happy to answer.